our day on the Big Ten says, consider the differential equation dy dx equals 3y squared over cosine of pi x. Let y equal f of x be a particular solution, which tells me we're going to find c. Okay. With the differential equation with a condition that 5 of 3 is -1, so that's one ordered pair right there, and they even give it back to you right here. The equation of a line tangent to the graph at 3, -1 can be written as that. All right, so let's see again. We are supposed to find the particular solution to the diffie-q. So what we're going to do right now is I'm going to separate this thing. Okay, so let's see what we got here. Oh, okay, we'll worry about that in a minute. So dy, the y is going to be on the left side, and the x's we're going to keep on the right side. So I'm going to take and divide each side or multiply by 1 over y squared on each side to get that over there. I'm going to leave the 3 over here, but I'm going to kind of scoot it over as a coefficient and leave this as 1 over the cosine of pi x, and I'm going to multiply the dx over to this side. So anybody got questions so far? Okay, so I've got, okay. So we are going to integrate this side, and we're going to integrate this side and see where we go. So I need to take this y, since that y has a square there, am I going to be doing natural log? No. The only time you can do a natural log is when it's x to the x, y, whatever variable to the first power. So I've got to move that y squared up to the top. So it's going to be y to the -2 power. And over here, let's see how we want to do this. 1 over cosine. I'm half tempted to make this into secant. So I think we're going to change this into secant. So we're going to move, because the reciprocal of cosine is secant, we're going to move this and make this secant of pi x. That is the reciprocal identity for cosine, is secant. Okay? So on the left side, we got to add 1 to the power. So -2 plus 1, I believe, is -1. I'm going to stick that underneath. And over here, we got this 3 in the front. Does anybody know what the integral of secant? What's the integral of secant?
The natural log of the absolute value of secant x plus tan x.
Okay, I'm going to write down what you said. Now, what's wrong with that? Don't write that down. You have to erase it. What's wrong with that? Yep.
That's the derivative.
No, the derivative of secant times. Okay, let me find the sheet. This is one of our integrals. Let me put it up there. He's got it. You guys need to know these. Okay, there's a couple mistakes with it right now. I don't know if you guys see them all, but there's a couple. So here's our secant right here. So there it is. He's got the right one up there. But we got a couple problems right now. What are they? Okay, 2 problems. One is my variable, my angle, just a regular old x? No, so what do I have to use? U substitution. And you're going to use U substitutions most of the time on the AP test, okay? So get used to it if you don't know it. So we needed to say U is going to equal pi x. So du is going to equal pi dx. And this kind of is that question you were asking about earlier. So if you look, I've got this 3 out front, which is coefficient, so I don't really need to worry about it. But I need a what dx in order to put a du in. What am I missing? I'm missing pi. Isn't pi a number? Are we allowed to create and destroy numbers? So I'm going to create a pi. I'm going to move this over. I'm going to create a pi create a pi, and come out here and destroy that pi. So this is going to be over pi. So what that does here is this makes this secant u, the natural log of secant u, tangent u. Now what else did we forget? Yeah, we didn't put our plus c on there. We got to have our plus c out here, okay? All right, so there's my equation. So I'm going to rewrite this thing over here as -1 over y to the first. Okay, I'm going to move that down to the bottom. I guess I don't need the first. It's going to equal 3 over pi. Natural log of secant u plus tangent u plus some c. Okay, what do I got to do now? Okay, there's a couple things I need to do. One is I need to come back in here and put this thing back in for you. So I'm going to put pi x here. I'm going to put pi x here. Now, what am I trying to find right now? Do I know? C. I want to find C. If you want, you could solve this for y. You can multiply both sides by -1, and then you would flip this one upside down, or multiply by y and divide this, or you can flip this one upside down, which means you flip this one upside down. So this would become pi over 3, and then it'd be 1 over that mess. You see what I'm saying there? Do we understand that? Like if I have 2/3 equals 4/6, which is true, if you flip this side upside down and flip that side upside down, it's stay equal. That's what I'm saying. So see, this whole side over here, this part's over 1 right now. So you can put a 1 over this part and be okay. But I don't want to do that. I think that makes it harder to solve the problem. So what I'm going to do is I'm going to take my point and plug it in now and try to solve it, okay? So I come over here and I got -1 over, and the y value is -1. So I'm going to stick that there, which is kind of sweet. We get a 1 there. Okay, and then over here for x, I got to plug in 3. So this is going to be 3 over pi, natural log of the secant of 3 pi plus the tangent of 3 pi plus some c. Okay, there. All right, so now I got to figure out what 3 pi is. So let's look down here. I hope we know our unit circle. This is 0. This is 90, or let's use pi over 2 since we're in radians in this class. There's 1 pi. Come back around, that's 3 pi over 2. And this is 2 pi, and we're going to go all the way back over here. This is 3 pi again, right? So pi and 3 pi are in the same place. So my ordered pair here is a -1 and a 0, and your radius is 1 because this is the unit circle. So do we know what secant is? Does anybody know what secant is? So we need some trig review, right? All right, so we're going to go through this. On the unit circle, sine is y, the cosine is dx. Now we usually put them over r, but your r is 1, so y'all see what I'm not putting over r, because this is a 1. If you want to put them over r, it's over the radius. And then tangent is y over x. And then what do we do to get cosecant? Anybody know? What's cosecant compared to sine? It's the reciprocal, right? And this is y over 1, so this is 1 over y. And secant is the reciprocal of cosine, so this is 1 over x. And then cotangent is the reciprocal of tangent, so this is x over y. Now, you're supposed to know this. And I know we all got screwed over. We've been screwed over for over a year now because you're not in school yet. Some of you are screwing yourselves over from the point that you're not doing what you're supposed to do on the days off. When you're not at school, some of you are taking days off. Don't do that. Come to Zoom. There's not one kid in your class that's at Zoom right now. All right, so secant is 1 over x. Well, the x value is at -1 right there, right? So 1 over -1 makes this thing -1. Oh my gosh, we got a problem, don't we? So we come down here and we do tangent. It is going to be y over x, which is 0. And we got a plus c out here. I guess we don't. We got absolute value there, right? What's -1 and 0? And the absolute value of -1. All right, so what's the natural log of 1? So 0 times 3 over pi makes this all 0 plus c, so that means c equals 1. Okay, all okay there? All right, so we're going to come up here and put c equals 1. All right, so c is 1, and now we're supposed to solve this for y. What'd you say?
You didn't have to do all this stuff.
Why? It says, oh, I thought it said, my bad, I misread it, my bad. Yes, my bad, I read this wrong. I thought we were finding a particular solution, but it just says, let this be a particular solution. And then it says the equation of the tangent line can be written as this, find b, my bad. Okay, so this could have been a lot easier, my bad. It's still helpful. All right, I should have not done that. I should have said that y equals mx plus b is my equation, and then I'm going to plug in my stuff and find b. So y is this -1. M is this thing right here. Let's not put that -1 in. So y is going to equal 3y squared. I was finding the particular solution, and I didn't have to. And then x, we're going to leave x plus b, and then we're going to plug this point in for all the x and y's. Yeah, this is way faster, but some of you could have used the help with the doing the substitution deal. Let's see, 3x, 3 pi plus b. Now we're going to solve that for b and we'll be done. I didn't read the directions right. I thought we were finding that. So the cosine of 3 pi we just did a minute ago, right? It's -1. This is -1 right here. Okay, and then this is 1, so that's 3. So -1 times -1. Actually, we have to, what do we do? We get 3 divided by -1, so that's -3. Plus b, so b is 2. I did not read the directions of the whole problem. That's all you had to do. Yeah.
What's the record about 8?
Yeah.
Because, so we
Yeah, I
just
know.
like, you plug the point into, dy over dx to get the slope, and then you plug, so the slope is -3, and then you plug that into.
Oh, I left the x off. My bad. You're right. I left my x off right here. You see that? I left my x off there, so I need to plug 3 back in right here. 3 had to go in for that x right there. I left it off up here. There should have been a -3 here. That's what I did wrong. I accidentally dropped the x off. So that makes that -9, right? That makes that -9 over there. And then you add 9 over, so b should have been 8. So I screwed up because I dropped that x off over here. Y'all see what I did wrong? Thanks for yelling that out for me. All right, part C. Part C says, consider the Diffie Q here. Let h, the y equal h of x be a particular solution of the equation of that. Find the limit as x approaches infinity of h of x. All right, so we're going to have to find a particular solution and then take the limit on that. This is not like the ones that we were doing where they gave us a direct variation thing. This one's harder. So we're going to have to find y, and then we're going to take the limit as x goes to infinity to figure out what this is. So this is pretty intense stuff right here. All right, so we're going to keep the x squared on the right side, and we're going to multiply the dx over with it, and then I'm going to leave the 2 here in front, kind of like I did that 3 a little while ago. Okay, it's a coefficient. The 2 is, if you want to put it on top, it's 2, doesn't matter. And then I'm going to divide by y over here. So this one is going to be a natural log when I do the integral. So this is the natural log of the absolute value of y is going to equal 2. And now I got to think of this as being x to the -2 like I did a second ago, because this is not to the first power, so it's not natural log. And some people in this test coming up try to put natural log on everything, and they're not all going to be natural log. So I got to add 1 to -2, which is -1, and divide by -1. And then I got plus some c out here. Okay? Now I'm going to take this -1 over here with the 2 and put that as -2, and I'm going to make this 1 over x. And I'm gonna go ahead and multiply this back and put -2 on the top. Okay? Now, what I've been doing, do you guys want to plug numbers in now to find C, or do you want to plug in numbers after you get rid of natural log? I like getting rid of natural log. I don't care. What do you want to do? All right, we're going to E both sides. So I E this side and I E this side. E to this power and E to this power. So I'm going to get Y, because these two cancel out, is going to equal. Now, I probably should write a different step down, but I don't have much room, so I'm gonna be thinking of this as this E to that power times E to this power, and this whole thing right here is another C. We'll put that C in the front, and this is E to the -2 over X power. Okay? And I've gone through this a million times in videos. Now I'm gonna plug this point in and get my stuff. So Y is 5 over E, which is going to equal CE to the -2 over 2. Okay, now you're going to have to go ahead and solve this thing. And then you're going to do the limit as X approaches infinity. You remember the story I told you about the cookies? That I like chocolate chip cookies, and I'm going to share those with everybody? Well, what's going to happen in this, I'm assuming, is the cookies are going to make that go to 0. And that part goes to 0, so your limit's going to be what's left. And if you need to see this more, I will finish it. If you want me to go ahead and finish that, tell me. I'll make a video today, 6 periods. So if you want me to finish that problem, send me an email to finish it, and I will. On machine.